All right, well, welcome back to Virtual Science 2021. We're going to pick up where we left off last week with classification of matter. We had talked about the classification of matter in the last class and how it was classified basically as pure substances or mixtures. And if it was a pure substance, it was either an element or a compound. And if it was a mixture, it could either be even, and it was the same all the way through. So it could be homogeneous, which the prefix homo means the same. Like if you were homozygous, you had the same traits from your parents. And heterozygous, they were different. So a heterogeneous mixture means it's not the same all the way through. It's different. You can see that it's not evenly mixed. And then there were couple of different kinds of homogeneous mixtures. There were alloys of metals that we melt down and mix together. And liquid or gases were called solutions. So like air is a solution. Hopefully it's the same all the way through. And then if it was heterogeneous, it could be either just some kind of mixed up stuff, or it could be a colloid or a suspension. So the first question that you were supposed to do on your own was say, what's the difference of an element or a compound? Now, the answers to these are on the page that we just did. Elements are atoms that are exactly alike. They're found on the periodic table. There's only about 90 elements that naturally occur in nature. Okay, so when you think about it, that's not very many ingredients to make everything out of. So when we break everything down to its smallest part, like if we broke water apart, which is hydrogen and oxygen, we would end up with two elements. We would end up with the element hydrogen and the element oxygen, and that's it. You really can't go any farther. If you break it down past that into protons or neutrons, it's not going to be like hydrogen or oxygen anymore. It's going to be a nuclear reaction. Okay. And then this next part here says, well, it's a mixture. A mixture is two or more substances, which could be elements or compounds. So we could mix an element together in a compound, or we can mix two compounds. Like salt is a compound, it's NaCl. And water is a compound, and we can mix them together, and we have salt water. Physically combined, which means there's not a chemical reaction. And there doesn't have to be any exact ratio to make a mixture. And mixtures can be physically separated. So we could get the salt out of the water by boiling the water or evaporating the water, and then the salt would be left behind. And if we captured the water vapor, we could condense it and make it back into water. Okay, what must an element have after its name? Okay, it needs to have this element symbol, like O is for oxygen and H is for hydrogen. A compound has to have a formula, like water is H2O and carbon dioxide is CO2. The two basic kind of mixtures are homogeneous, which are evenly blended. They look the same all the way through. So like Kool-Aid. You stir it in there, the water is the same all the way through. Or like if you make iced tea. Heterogeneous mixtures, it is not the same all the way through. So you can see differences in it, like in Raisin Bran or the cement on the sidewalk. You can see the particles and the rocks, and it's different. Okay. Down here, we were going to compare and contrast homogeneous and heterogeneous, and I said use this Venn diagram. Homogeneous mixtures are blended evenly. Metals are called alloys, so you melt the metals down and you pour them together and stir them up. But when they're mixed, they're the same all the way through. Okay? It's a liquid or a gas, the homogeneous mixture is called a solution, and we could add down here that light will pass through a solution. And it won't get broken up like on that video I showed you on the last tape. That man shot the laser through the clear mixture, and then it got scattered in the coupled. Okay, over here on the other side, for heterogeneous mixtures, they're not blended evenly all the way through. be either a suspension or a colloid. And the particles are bigger than solutions. This is why they scatter light, because the particles are big enough in these heterogeneous mixtures, they don't settle. And then here in the middle of the Venn diagram, what's similar about both a homogeneous and a heterogeneous mixture? Well, they're both mixtures. They can be separated by physical means. That means we don't need to process them chemically. We get back exactly the same ingredients that we put in. So like the example I gave you with salt and water. You separate it and you have salt and you have water, and you can remix them. We saw the kids separate. They had a mixture of iron and sand. The iron was iron mixed with the sand, and the sand was sand. And they separated it with the magnet. They got the iron out and they got the sand out. So when we say physical means, nothing changed. It didn't have a chemical reaction. Whereas if we separated the water molecule up here into hydrogen and oxygen, hydrogen is not water and oxygen is not water. So we would have, that would be a chemical means, we would have different substances at the end. Okay. And both mixtures can either be a solid, liquid, or a gas. Okay. So, all right. And sometimes all these definitions are confusing. Okay. And sometimes it helps to lay them out on a graphic organizer like this. It's in your notes. So we're going to take a look at that. Okay. Now, matter, okay, is anything that has mass and takes up space. And I added that definition here because it never hurts to review. We have all the matter on the planet, everything that is. Okay. It can either be pure or it can be not pure. So like when we classify things, they can only, remember we said they can only fit into one group. That's why when we classified animals, they were vertebrates or invertebrates. They either had a backbone or they did not have a backbone. Okay. They were an animal. They can only fit into one group. Okay. You can't say like, well, we're going to classify animals by whether they're like tall and they have fur, or they have paws. Because there's a lot of animals that are short that have paws and they could fit into more than one category. So when we make classification systems, they have to be classified so that they fit into only one group. So everything could either be pure or it could be not pure. If it's pure, it's a pure substance. And there are two kinds of pure substances. There are elements. And the way we know something is an element is it's on the periodic table. It means all the atoms in the sample are going to be the same. And that's kind of the key word, that all the atoms are alike. And some examples of elements are oxygen, gold, and hydrogen. So there's a simple O for oxygen, AU for gold, and H for hydrogen. Now, the other kind of pure substance are compounds. And there are all kinds of pure compounds. A compound has a formula. Okay. So it's two or more atoms or elements that are bonded together. So in this case, we have the element hydrogen. And in this compound, there are two hydrogens. And it's bonded together to one oxygen. Now, the properties of the compound are nothing like the properties of the two separate elements. Oxygen is in the air we breathe, and hydrogen is as well. Okay, so when we put them together and make the compound water, they're not the same at all. Carbon dioxide is another example of a compound. Carbon is what's in graphite in your pencil. Your pencil lead is not lead at all. It's actually graphite, which is pure carbon. And again, the oxygen is in the air that we breathe. When we put it together, it makes CO2, which is what we exhale after we have gone through respiration. So again, this compound is very different than the elements that it came from. Now, if we look at something and it's a sample of matter and we say, okay, well, it's not pure. It's not pure water. It's not pure carbon dioxide. It's salt as a compound. It's not pure salt, or it's not one of the elements on the periodic table. And we figure it's some kind of a mixture. Okay? And the first kind is a mixture that's blended the same all the way through. It doesn't look different. All the parts of the mixture are exactly the same. So the example I gave you is like Kool-Aid. Okay. The Kool-Aid, hopefully at the top of the pitcher, looks just like the Kool-Aid in the middle of the picture. You can't see any separate parts or things that make it up. Okay. Now, once we decide it's a heterogeneous mixture and it's the same all the way through, if it's a solid, okay, the one that we're going to think about this year are alloys, which is a mixture of metals. So most of the time, people don't use pure metals. They melt them down and mix them together. And when they make the mixture, it has better properties and it might be stronger or shinier and it's pure. So for example, gold in most jewelry is an alloy. Pure gold is very soft, so you could bend it with your hands. So it wouldn't be very useful to make a ring out of, or jewelry out of pure gold, because it would bend and dent and it wouldn't hold its shape. People mix a little sometimes zinc or copper into it, make it a little harder so it's practical. And that's when you buy gold or jewelry, that's what the carat stands for. 24 karat would be pure gold, and then 18 karat would have some elements into it. And so it makes it so we can use it. Okay. And then sometimes people buy like aluminum alloy wheels. Aluminum by itself is light, but it's very brittle. So they mix other metals in there so the wheels on a car don't crack. Or if you have an aluminum alloy that maybe has some titanium in it to make it stronger. Okay. If it's not a solid, then it's a liquid or a gas. And if it's a liquid or a gas, it's called a solution. Okay, so we have these homogeneous mixtures that are same all the way through, solids or alloys. Solutions, which are liquids or gases, are still the same all the way through, like Kool-Aid or salt water. When you mix salt and water, you can't see the different parts of the solution. It's the same everywhere in the salt water, like a gas, like air. In the air that we breathe, okay, we know we're breathing out carbon dioxide, so that's in this room. The atmosphere is made out of mostly nitrogen, which is another gas. And there's oxygen in here, and you know there's oxygen in here because I'm alive and I'm breathing it in to stay alive. So there's at least 3 gases in the room that you're in and the one that I'm in. So they're mixed together, but it looks the same all the way through. The ceiling doesn't look different than the air at the middle of the room or at the ground, and you can't see parts of it. Okay. So air is a good example of a solution that is a gas. Now, if this mixture doesn't look the same all the way through and is perfectly even, then it is the prefix homo, means the same. So we have a prefix where it's not the same. So we have this mixture, it's not exactly the same all the way through. If it's a solid, like raisin bran, it's just some uneven mixture. If it's a liquid or a gas, it could either be a colloid or a suspension. And an example of a colloid would be smoke or milk or jello. On that video, that guy had that cloudy liquid and he shined a flashlight through it and it scattered the light. That's because the particles in the colloid are bigger than in a solution. So they're big enough when the beam of light goes through it, it bounces out and it gets broken up and it scatters there. In the smoke, milk and jello do the same thing. Okay. If it's a liquid or a gas, it could be a suspension. The thing about suspension, now the particles in a suspension are so big that they don't stay mixed if you stop shaking it. Okay, so things like muddy water or a river delta or a pond, sediment settles out in the river delta or the pond, muddy water, it settles. So it doesn't stay mixed all the way through. Now, things that you have at home, you buy, say Shake Well, they're all suspensions inside that bottle. So like any medicine you get or salad dressing or anything like that that say Shake Well, the manufacturer knows that inside the bottle it's a suspension, so it's separated and the heavier part settled to the bottom and the light part settled to the bottom. So if you don't give it a good shake, then it's not going to be mixed up when you use it. So even like spray paint, you have to shake the can before you use the spray paint because they know it's a suspension inside the can. Okay. I had this little slide of some different elements, compounds, and mixtures. Okay. This Polo, okay, this deodorant in here. Do we find that on the periodic table? No. Okay. Does it look like it's just one compound, or if we flip this can around, would it have different ingredients in it? Well, yeah, we know it's going to have more than one ingredient, so it has to be a mixture of something. So it's not a compound. It's not a pure substance. It doesn't look like a solution. It's not clear enough that we can see through it. And hopefully it's not a suspension and the deodorant's going to settle out on us. So it's a colloid, okay? It's not pure. That knocks out elements and compounds. And we know it's a mixture and it's not a clear solution. And it's not a suspension and settling. Look at this mayonnaise. Okay? You know mayonnaise isn't an element on the periodic table. If you look at a jar of mayonnaise, it has different ingredients in it, so it's not pure. So that knocks out pure substances, elements, and compounds. It's not a solution. Light's not going to pass through this. It's not clear. And it's not an alloy of metals. So our next group over is, could it be a colloid or a suspension? Well, it's not going to settle like a suspension, so it must be a colloid. And if we had bright light and shine it through the mayonnaise, we would see it scatters like the colloid. So if we said it's not pure, it knocks out elements and compounds. It's a mixture of some kind. It's not clear like a solution, and it's not a suspension, which is settling. So it's a colloid. It's the one in between. Right off the bat, we're looking at this salad dressing. What do we see down here at the bottom? This brown stuff, and then this stuff is settled, and then up at the top is the oil and the vinegar, and it's settled into different layers. If it's settling, we know it must be a suspension. Okay? You can see it's settled into different layers. It is whipped cream. Okay, first thing we do, look at our graphic organizer. Is it pure substance? So we find, is it an element? Well, whipped cream is not on a periodic table. It's made out of dairy products. Okay. Is it a pure substance? Is it just one compound? Well, if you look at a can of whipped cream, they put sugar in it and milk in it, so it's a mixture of some kind. Okay. The first kind of mixture would be the one with the smallest particles would be, is it a solution or a malleable? Is it homogeneous? No. This is not clear like a solution. Light is not going to pass through it, and it's not a mixture of metals where the metal melted it down and mixed it together. It's an alloy. So we go over to the next particle size up. Okay, so it can either be a colloid or a suspension. Well, when we look at it, hopefully this whipped cream is not going to settle. If it is, we shouldn't eat it. So it's a colloid, and if we shine light through the whipped cream, it would scatter. Okay, so it has particles in between a solution and a suspension. Okay, so like I said here, it's a colloid because it's not pure. It's got elements and compounds. It's a mixture of some kind. It's not clear like a solution, and it's not a suspension because it's not settling, so it has to be a colloid. This milk. Okay. Milk is not a pure substance. If you look at the ingredients, it's got water and milk products, dairy products in it, different things. Okay, so Since it's not pure, that knocks out elements of compound. So it's got to be a mixture of some sort. First question is it a homogeneous mixture? We look at it. The two choices for homogeneous mixture would be an alloy, which is a mixture of metals, and let's hope not. And is it clear, like a solution, like a liquid or a gas? Well, it's not clear. Light is not going through it. That leaves us with the choice. It could either be a colloid or suspension. Milk is not going to settle, so it's not a suspension. And if we shine a flashlight through it, it'll scatter light, so it's a colloid. Its copper is a pure substance, and we see here its symbol, Cu, is found on the periodic table. So that means it's an element. It's pure, it's found on the periodic table, so we know it's an element. It's Jello. When you make Jello, you put sugar in the Jello and the gelatin and a bunch of different stuff in it. So you know it's not a pure substance. Jello is not an element on the periodic table. It's not just a compound. We said we mixed a bunch of things together, so it's got to be some kind of a mixture. So we start off with the smallest particles. Is it a solution? Choices for solution. Is it an alloy of metals? Well, no. Is it clear, a liquid or a gas where you can shine light through it? No. You can't even see the table on the other side of this Jello. So the next question is it a colloid or a suspension? Well, hopefully it's not a suspension. It's not a settle. So it's a colloid. Okay, this causality is not pure. We can clearly see that this is a mixture. It's an uneven mixture. It's just a heterogeneous mixture. This is the river delta at the end of the Mississippi River. It's what settles out and adds to this land down here. So if it's settling, it must be a suspension. This cloud, it's not pure, it's not an element or a compound. So it's got to be a mixture. It's not clear like a solution, and it's not an alloy of metals, so it's not homogeneous. That means it has to be heterogeneous somehow. It scatters light. Okay, so this is a colloid. And again, this river delta is a suspension, okay, where the mud comes down the Mississippi River, it settles, and it actually forms these islands and these areas out here off the coast. This isn't, obviously this is not pure, so it's not an element or a compound. Okay. Is it a homogeneous mixture and the same all the way through? Well, no. You can see the beans and the rice and all these different things in here. So that means it's a heterogeneous mixture. And it's not a colloid. It's not a suspension. It's just a heterogeneous mixture. Okay, obviously, this is a mixture. It's just a heterogeneous mixture. It's not one of the special ones. It's not a colloid or a suspension. It's orange juice. What do we see here? Sometimes it comes with pulp in it, and sometimes it doesn't have the pulp in it. And here at the bottom, we can see that something settled out, a different color. If it settles, it must be a suspension. Okay, and that ends our lesson for today. I hope you guys are doing well, and we'll see you next time.